Hi everyone, this video will go over the concept of firewalls and the iptables firewall suite to give a good overview of how you can configure a firewall on a server, and it's intended to help with pursuing the extra credit on Homework 5. So the entire idea of a firewall is setting up rules that will allow you to selectively accept and drop traffic. The idea is that some traffic is trusted and other traffic is untrusted, and so we want to make sure we are only allowing that trusted traffic and dropping anything else. So in this diagram here, you can see that there's this server over here, and we can imagine that this is our own server, the one that we are configuring. And there's these two rules over here. This first one says, if you are accessing my TCP port 22, accept. And the second one says, otherwise, drop. So this first rule is essentially saying, if you are trying to communicate with me on SSH, then I will accept that traffic. And then the second rule is a catch-all rule, which is at the bottom of which is at the bottom level, and it says that if any rule didn't match, if this rule did not match, then drop the traffic. So you're effectively creating a whitelist, which says that SSH traffic coming to me should be accepted and all other traffic should be dropped. So let's suppose we have this computer over here that is trying to initiate a communication. So this computer will try to initiate an SSH session into our computer. That communication comes from a source port of 4827, which means that this computer has opened up a TCP socket on port 4827 and is trying to communicate with TCP ports 22 on our computer. This packet will be processed by this computer, and it'll see that the destination port is 22. So the source computer over here is trying to access us on port 22, and so it gets matched by this first rule. And the action for that rule is accept, and so the traffic gets accepted. We can suppose that if this computer was trying to access some other service, like let's suppose instead of SSH, we were trying to access HTTP. So instead of using port 22, we were using port 80, TCP port 80. Now when the communication comes over, this computer will send traffic to our port 80. When our computer is processing this traffic, it'll go rule by rule. So it starts at the top. It says, if you are accessing my TCP port 22, accept. And this is the condition for that traffic. The destination port must be TCP port 22. However, our computer, or this packet, does not contain any destination port going to port 22, and so the traffic the packet gets dropped because it does not match this rule, but it does match this catch-all rule. The entire idea of firewalls is to differentiate traffic that we should allow and should not allow. And in this case, HTTP would be blocked, but SSH would be allowed. So we can kind of realize this type of setup using iptables. Iptables is the kind of standard for setting up firewall rules on most Linux distros. It has a few flags that we can use in order to set up an effective firewall. So each firewall rule is one iptables command. Each command can specify what type of traffic to either accept or drop in that one specific rule. So for example, if we wanted to, actually let's just go flag by flag. So the -A flag in iptables will allow you to specify whether you're trying to parse input or output traffic. Input means traffic that is coming to our computer, and output means traffic that is coming out of our computer. And when I say our computer, I refer to the computer on which you are running iptables commands. So if you are configuring iptables commands on your own laptop, let's suppose you have a Linux laptop, then if you're talking about input rules, you're specifically trying to match traffic that is coming to your laptop. If you're trying to match output rules, you're talking about traffic that is going out of your laptop, so communications that you are initiating. Next, we go to the -P flag. -P will allow you to specify whether you're talking about TCP or UDP traffic. TCP is the transport level protocol, which guarantees in-order delivery and reliable streams, whereas UDP does not care about that. All it cares about is latency, so it can deal with potential drops and potential missed packets or incorrect ordered packets. All it cares about is latency. And so TCP is great for things that really require reliable connections, like SSH connections. It's also used in HTTP, whereas UDP is used for anything that requires very low latency. So voice calls, video streaming, and things like that. The -p flag is technically optional. You don't need to include this if you are not talking about protocol-specific matching. But if you want to talk about specific applications or specific ports, then you would want to include these flags. If you want to not just broadly match TCP and UDP traffic, but want to match specific ports within TCP or UDP, then you can use the port flag. So the first one is source port or S port over here, which will allow you to filter based on the source port of the communication. And then you can also use destination port in order to filter based on the destination port. And so you can also use, and lastly, after you've matched any port and the protocol, you can specify the action. So deciding whether to accept the traffic or drop the traffic. And you do that using the -j flag. Put together, we have this command over here, which says iptables -a input -p TCP -destination port 80 -j accept. What this means is traffic that is input, that is coming to us on TCP port 80 should be accepted. Now, it's a little bit confusing, the distinction between destination port and source port, but we can suppose that if this said S port instead, if this said source port instead, then it's no longer talking about communications that are going to us on port 80, but communications that are coming from someone else on port 80. So if you have a command like this, instead of referring to allowing traffic to the HTTP server that is running on our computer, it is saying allowing traffic from someone else's HTTP server. Because a source that is coming to us, that is input to us, the source port would refer to the other computer, whereas the destination port that is coming to us would refer to our computer. So it might be a little bit confusing, but I would recommend referring to kind of this example over here, where we're talking about SSH traffic on port 22. The arrow here is representing the source going to destination. And so this rule over here is filtering based on destination port. And you can see that this packet over here has 22 as the destination port, which means that when we receive this traffic, we're seeing that the destination, which is us, because we're talking about input traffic, is 22, which we are accepting. All right. The next flag we can talk about is the default policy flag. So this would be standalone. You would not include all of these flags. It's kind of standalone from like this type of command, in the sense that you're setting a default policy which says that if traffic doesn't match any specified rules, then we can choose whether to accept or drop traffic. So for example, if you run iptables -p input drop, what you're saying is if the received packet doesn't match any rule on the input chain, then we should drop that traffic. And so the reason why I said that this command does not include any of these -p or port flags is because this is a default policy. So you're not specifying anything about the traffic. You're just saying that if it doesn't match any of the specified rules, then it should be dropped. So it's kind of like a catch-all, kind of like we saw in this example over here. So you can realize this type of rule using that -p flag, which sets the default policy. So in this case, the default policy is to drop. And so if you have a line like this, which says iptables -p input drop, then you're saying the default policy would be to drop. So real quick, you can pause and just look at these two commands and see what they do in conjunction, and just think about that for a moment. So if you have this first rule, what you're saying is iptables -a input -p TCP destination port 22 should be accepted. And put into English, that means traffic that is coming to me on SSH should be accepted. And then we have the second rule here that says iptables -p input drop. In English, that means the default policy should be to drop. So we have this first rule, which is specifying what type of traffic to accept. And it's specifically saying that SSH connections should be accepted. And then we have the second rule here, which is saying that if the default policy should be to drop. So in other words, SSH should be accepted and everything else should be dropped. That's what these two rules do in conjunction. And I have this little simulator here that I've used in previous club workshops that you can use for just testing things out for the assignment. I'll put a link to it in the description, but we can just try running these commands first. So let me first try running this first command. I'll just copy and paste it. And then let me try running the second command. So the way that this simulator works is you can choose what source IP address to send your communications from, and then you can choose what port and protocol you're trying to access. So these would be the destination ports that you're trying to access. This IP table, this command prompt here is one computer, and this panel on the left over here is another computer. And so by default, it's just set to trying to communicate with SSH. We can try sending traffic, and we see that it is accepted, that traffic is accepted. Now, if we try changing this port to something else, like port 80, and then try sending, we can see that we're now getting drops. All of that traffic is getting dropped. The SSH connections were accepted, but the HTTP connections were dropped. And so feel free to use this tool as a tool to help build your firewall if you just don't want to test things on the actual server during the assignment. So let's suppose we had this rule over here, this rule that was saying we want to allow communications to our SSH and drop everything else. Let's suppose that this server is a Debian server and we're trying to get package updates. And so we send traffic from port 53592, which is a random high number port, to port 443. The fact that this is a random number is somewhat relevant. On most operating systems, whenever you're trying to access any service, your kernel will give you some random high number port as the source port for the communication, which is just to make sure that it doesn't collide with any services that are running on your computer. So most services, like for example HTTPS or HTTP or SSH, as we've seen before, use low number ports. So that would be ports below 1024 or around that range. And so those ports would all be protected. So they're reserved for running services like that are critical on the internet. And then the high number ports are unreserved. They can be used for any application that just needs to send traffic. And so if we're trying to access package updates, then we could be sending from a source port of this high number port that our kernel assigns to us, and then with a destination port of port 443, which is the reserved port for HTTPS. So this packet that we're trying to send in order to request package updates is coming from this port on our computer and going to port 443 on this computer, on the Debian package repo mirror server. So we send this packet over to them. Their server then responds saying, hello, Cybersecurity Club server, here are your updates. The source port for this communication is port 443, and the destination port is this high number port that we sent the traffic originally on. Then we're reminded of the firewall rule, which says if you were accessing my TCP port 22, then accept, otherwise drop. So this packet is received by us and is filtered through our iptables firewall rules. But because the destination port that for the accept only specifies port 22, and this destination port over here isn't 22, it doesn't get matched by the first rule. It gets matched by the catch-all, by the default policy, which says to drop. And so this packet, which we initially sent, and so we know it's trusted, gets dropped because it doesn't match our rules. And keep in mind that this port is randomly generated by the kernel and assigned to the application that sends the package update request. And so we can't just create a new rule that says allow traffic to port 53592 for two main reasons. One, because that port is randomly assigned, and two, because let's suppose a backdoor is put in our system and the hacker that puts that backdoor there knows that port 53592 is allowed by the firewall. Then they could create a backdoor that specifically listens on that port. And so we've basically created another vulnerability. And so we have in our minds the comfort of having a firewall, but it's an imperfect firewall that has been taken advantage of. And so we want to make sure that these high number ports are dynamically added to the list of allowed ports. The way we do that is using a stateful firewall. So if our computer sends outgoing communications, we should accept the responses dynamically. And this is known as keeping track of state. State refers to the parameters of a packet that include the source IP address, the destination IP address, the source port, and the destination port. So if those 4 values match for a traffic that comes back to us as traffic that came from our computer, then we know that the communication has been established and is trusted. That's a bit of a simplification. There are some more specifics with how TCP works, but the entire idea is that our computer is keeping track of what packets have been initiated by us and which packets are essentially trusted. And so there's this sort of long command that you can use in order to get this information. It says again, I'll just read it out. It says iptables -a input -m contract -ct state establish related -j accept. So there's a few flags here that we've already seen before. -a input means input traffic, incoming traffic. -j accept means to accept the traffic, because of course we're trying to accept the traffic dynamically. And then there's these 2 flags in the middle. -m contract is enabling the connection tracking module within iptables. So connection tracking is what keeps track of the state. And then CT state, I believe, means connection state. And we're specifically trying to refer to established and related connections. So established and related connections include the traffic that we ourselves send out into the internet, and I believe it's like forked communications from something that has been established by us. So altogether, it's just referring to established connections. And there are other states that, I'll just mention them for the sake of example. Invalid is one state that you could put here, which would refer to, I believe there's invalid and there's new, are 2 CT state options. And those would refer to traffic that you should not allow because they are not started by us. And so if you can run this command safely on as part of your firewall, and it'll only allow traffic that is related or perfectly matches communications that you send out. And so it's only allowing back trusted responses. Just a word of caution, and I'll touch on this in a moment. Or actually, I'll just do it right now. So firewalls filter all traffic. And so you run the risk of accidentally locking yourself out of the system, basically permanently. So for example, if you only have SSH access to a machine, then if you set up a firewall incorrectly, then you might end up blocking yourself out of that system. You might end up locking yourself out of that system and basically preventing yourself from getting back in. So for example, on this homework assignment, the only way that you all can communicate with the machine is via SSH, right? The only way you can configure the system is via SSH. So make sure that you are always permitting SSH, and in the real world, just make sure you always have some way to get back in. For example, if you're setting up a firewall on your own laptop and you accidentally block SSH, it's not necessarily the end of the world because you always have physical keyboard and mouse access to your own computer, right? For the sake of this homework assignment, you don't have that. You only have SSH to access these machines. And so the word of caution I want to say is just don't sacrifice availability. In cybersecurity, we have this thing called the CIA triad. It refers to confidentiality, integrity, and availability. Confidentiality and integrity are 2 main aspects that, a lot of people, it'll come to mind when they think about security. Availability is something that sounds a little bit more foreign. It sounds like it's outside of the scope of security, but it is just as important. Availability is saying that the service can be accessed by those who need access to it. And so if you set up a firewall which blocks SSH, then you no longer have a way to get back in. You can consider the system to be secure if you're looking at it from purely a confidentiality and integrity standpoint, because now it just sounds like, nobody can get into this machine, nobody can configure it. Which, if you're thinking about it from the perspective of hackers, then sure, that's a good thing. But now you're blocking yourself out of the system. You're not allowing yourself to go in and install patches or fix vulnerabilities. And so you've sacrificed something that is really core. So just be very careful about making sure that you are permitting SSH. For this assignment in particular, if you're just thinking about it from the perspective of the assignment, there is a little bit of leeway that you can have. because iptables by default does not keep rules after resets. So anything that you configure in iptables will go away after you reboot your server, or I believe it does that at least by default. So if you do end up setting up wrong iptables rules that lock yourself out, we can just reset your box for you, and then it'll be fine. By reset, I mean reboot, not like fully wipe it, but just do a reboot of the system, and then it'll be fine. And we can do that for you. But for the, I guess, just thinking about setting up firewalls in the real world, there's a big need to be careful about the things that you configure. And yeah, that's about all I have to say about that. If you have any questions, feel free to put them in Discord, or reach out to me otherwise.